Hi everyone, this is Miss Englert, and I am showing you guys how the sun moves across the sky using this Motions of the Sun simulator. So right now I want you guys to look, our altitude, our latitude, easy to mix up. Our latitude of our observer is at 42 degrees north. We're still in New York State. However, I changed our date. It is now September 21st. So September 21st is our autumnal equinox. And I'm showing you at noon. I want to show you the sun's path as we go through the day, and I want you to show you real fast what our shadow does during the equinoxes. So during sunrise, when the sun is not out, we don't have a shadow, first of all, because we don't have any light to provide a shadow. So we don't have any light in the sky. So if we don't have any light, then we don't have any objects to block the light. Therefore, we don't have a shadow. So sun has to be up. We have to have light in order to have shadows. As the sun rises, so you see the sun in the sky, as the sun rises, you see that there is a very, very long shadow because the sun is low in the sky. As the sun gets higher in the sky, our shadow becomes shorter. And notice our shadow always points in the opposite direction as the hemisphere or which sky the sun is in. So if the sun is in the southern sky, our shadow is going to point north. As the sun sets on this autumnal equinox, our shadow gets very, very long and it points east until the sun sets. So I'm going to reset our clock to noon. I'm going to change our date. So real quick, this is what our sun's path looks like during the equinoxes. So if you look, half is above the hemisphere there, and then half is below, which means that half of our day is daylight, half of our day is nighttime. When I go to December 21st, once it's December 21st, look what happens to our circle. So now we have this tiny little portion of our circle is above the horizon. That means that's our daylight hours. And this now below, those are our nighttime hours. And then you can also look, here is where the sun would be at noon on the equinoxes. And then here's where the sun is at noon during the winter time. So that wintertime sun, the angle of that wintertime sun is going to have an effect on our temperature and also our daylight hours. So let's go back to now sunrise. So if you remember from the video for summer, our sun actually rose in the northeast. Oh boy. But here, our sun is going to rise in the southeast. So when our sun rises in the southeast, if you see it's very, very, very faint, you can see a little shadow there. Our shadow is going to point towards the northwest. As our sun goes higher into the sky, when we are in the southern hemisphere at about noon, our shadow is going to point towards the north, and then it's going to be still going to be pretty long. So if you remember the shadow of the equinoxes, our shadow was very short. During the wintertime, our shadows are longer in general. And then as we go back towards sunset, our sun is now setting in the southwest, and our shadow is still pointing towards the northeast. As our sun sets, our shadows get very, very long. So if you remember when I was toggling through these, it took a much longer time for our sun to drop below the horizon. I need to go back to noon because I forgot to address the altitude of the sun during this time of the year. So at solar noon, let's make sure that this is actually on the line. So at solar noon, go there, sun. This is why I recorded that other one so many times. Okay, there's our sun at solar noon. So notice our sun is in the southern sky and our shadow is pointing north. Our sun's altitude right here is 24.5 degrees. So you guys should have noticed that during each of these times of the year, so watch the sun's altitude here real fast. Let's change this to September. We have 48.3, and then we have June at 71.4. Between each of those, so between 71.4 and the second one is 23.5 degrees. That has to do with the tilt of the sun.